All right, hi you guys. We are now on section 6.6. We're going to be solving exponential equations and logarithmic equations. Remember that you can undo an exponential with a logarithm and vice versa. They are inverse operations. So we're starting out with what we already know. We've done this before. We know that algebraically, if b is a positive real number other than 1, then b to the x power equals b to the y power if and only if x is equal to y. So remember, if and only if goes both ways. Okay, and here's an example. So if you have the same base and different exponents, then these exponents, sorry that's scribble, are equal. So now what we're going to do is a few examples. Please write them down in your notes. There are a couple of different strategies. We're going to start with the first one, and that's where we want to change both sides to the same base if they haven't already been changed. So again, we've done this before, but here's an example. Say I have 6 to the 2x minus 6, and it's equal to 36 to the 3x minus 5 power. You should be able to recognize that 36 is equal to 6 squared. So we're going to rewrite it like this. Everything else stays the same. But if you remember your power rules, where if this is 2 raised to this power, then these are going to multiply together. And if you have the same base, they're both 6, then you can set your exponents equal to each other. So at that point, we now get, on the next line, 2x minus 6 equals 6x minus 10. We're going to go through these solving, so we end up taking away 2x from both sides to get 4x. We're going to add 10 to both sides to get 4 over here. Divide both sides by 4, x equals 1. And hopefully we are done. Of course, if you want to put the solution set, you would use the braces. Okay, we're going to do another example. New page. Okay, so our second example here is going to be, say I have 81 to the x power. And I also have on the other side 1 over 9 to the x plus 3. You should be able to recognize that this is a power of 9 and this is a power of 9. So we're going to change both of them into a base of 9. This is 9 squared, still to the x power. And 1/9, remember, is 9 to the negative 1. And that's to the x plus 3 power. So once we have the same base, then of course you can recall, this is our example, the exponents are equal to each other. So that's going to allow you to write on the next line, 2 times x is equal to negative 1 times x plus 3. So that'll be the negative. We're going to solve this by getting our x's on one side. So I'm going to add this x over here to get 3x equals negative 3. Divide both sides by 3. I get x equals negative 1. Okay, again, if you want to write it in solution set notation, that is negative 1. So far, that's what you know. Now, that was from a previous chapter. The next way that we can solve equations is that we can change into what we've now called log form. Once we get it into a calculator ready state, you can use that, or if you can figure out the exponent again, you'll be able to do it that way. I'll do both. So let's say I have 3 to what power equals 8. Clearly I don't know what that is, but what I could do is change this into log form. Okay, so remember that here's your base, so you're going to write log base 3, and then we want to know the answer. So this is where the 8 goes. It's always equal to the exponent, equal to the exponent. So if you recall from over a week ago, what you can do is change this into what we call calculator ready, and it's also called change of base. So if you want to just go straight to the calculator, x is equal to log 8 divided by log 3. Okay, so that's what we're going to put a CR by there, so it says calculator ready. If you do want to just pop it in the calculator, it is approximately 1.893. So the way that works is if you put in your calculator from the beginning 3 to this power, okay, if you put in 3 to the power, you'd get very close to 8. Here's another example. Say I have 7 to the 9x power, so it's a little weirder, and it's equal to 15. I want to get that exponent, that variable, out of the exponent. So again, I can rewrite it into log form. So it's going to be log base 7 of 15 equals the exponent. Here it's 9x. Okay, so you may not know what to do from here either. What you can do is you can divide both sides by 9, okay, to get just the exponent. And the way that's going to look is 1/9 times the log base 7 of 15 equals x. So to make that equal to calculator ready, it's going to look like this. Log 15 goes on the top, and then 9 times log 7 will be on the bottom. One thing to note, you will need to put these in parentheses when you pop it into your calculator, because otherwise it'll divide by 9 and then multiply times log 7. You don't want that, clearly. So the answer here that you should get, now that this is calculator ready, is x approximates 0.155. If you don't get that, go back and use your calculator again, okay? And so this will be the end of part 1, which is solving exponential equations. Part 2 will be solving logarithmic equations, okay?